friends, welcome to Insight Text. This is the platform to learn about power transmission elements and its control system. So friends, continuing in the part 2 of our video for overcurrent and earth fault relay, in this video we are going to learn about numerical relay. So let's just have a quick recap about what we have learned till now about the electromagnetic relay, and let us see what we are going to see about numerical relay in this video. We have seen some visual experience about electromagnetic relay, and in this video we will now see a new type of relay, that is numerical relay. Again we will understand some basics about settings of the relay, and further we will understand the connections that are made for the numerical relay. So friends, as you can see, this is the electrical diagram of electromagnetic relay used as overcurrent and earth fault relay. Basically, it works on the principle of Faraday's law of electromagnetic induction. Let us now move on towards different parts of this relay. The first one is the current coil. As you can see, this current coil is directly connected to the secondary of the CT, and it is connected on this C-shaped piece, in which on one leg this current coil is provided, and this basically is used to provide a operating torque to this aluminum disc over here. Now this aluminum disc is the heart of the relay, because relaying is done by the action of its rotation. Now how does it rotate? To rotate this, there is an arrangement of this shaded pole. Over here you can see two different flux are needed to generate a torque in this disc. So this shaded pole arrangement is used to create the phase difference between two flux. So this was the basic principle working about the electromagnetic relay. Now let us see how the numerical relay are working. Basically, numerical relay are microprocessor based relays. They do not require this kind of disk or electromagnetic laws to apply, because they are microprocessor based. So let's see how actual numerical relay looks like. So friends, as you can see over here, this is a numerical type overcurrent earth fault relay, or having ABB as the company, and it is called as PAS 140C relay of the ABB make. So different companies make different kinds of overcurrent earth fault relays, but the basic principle for them is same. And you can see over here on the display already they have given various kinds of faults. This LEDs will display on which line the fault is occurring, which phase the fault is occurring. Then on the back side, as you can see, there is a provision for connections that we receive from CT MK box inside the panel, as we discussed in the CT MK box wiring video. See, this is the connections for R phase, Y phase and B phase. Then on the other side, there is provision for connections that are to be given to the circuit breaker, or either through direct to the breaker or through the master relay. And annunciation wiring can also be done through this context provided over here. The LED display is given that will display the amperes whenever there is any kind of fault occurring. So that's all for the numerical type of relay. Settings of overcurrent and earth fault relay, most interesting topic. So to understand the settings of this relay, we first have to understand what is IDMT curve. IDMT basically it means inverse definite minimum time curve. We are using IDMT curve for doing the setting of this overcurrent and earth fault relay. So what this basically curve indicates, as you can see over here, is on the x-axis there is current, and on the y-axis we have taken time. So based on the graph, as you see, when there is minimum current, when my current is less, the time taken by the relay to operate or to send the trip command is more. But as the value of current is increasing, the time taken by the relay to operate is minimum. So as the name suggests, inverse definite time, right? So more the current, lesser the time, and less the current, more the time. Why this kind of setting is done? because when the current is minimum, the relay will give you some time for fault clearing. It will give some time for the fault to clear itself. If it is a high surge, instead it may be a maloperation if it operates instantly. Okay, so it will give some time for the relay to operate. Okay, and that time is fixed, some definite time. So now we know that based on IDMT curve the setting are done. So as we saw in the video that there is a provision for plug setting multiplier selection over here, and this is a time setting multiplier. Okay, so now let's see how this plug setting is done. Okay, so for example, let us consider the CT that is connected for this feeder is having the ratio of 300 by 1 ampere. Okay, so based on that ampere capacity, we can, as you can see, we can do the plug setting 0.5, 0.75, 1, 1.25 and so on. So how to interpret this is 2.5 means to set the setting, plug setting to 50%. 0.75 indicates to have the setting up to 75%, 100%, 125% and 150% and so on. Okay, so what does this mean is, say suppose if the CT ratio is 300 by 1 ampere, 50% of this means 150 amperes. What does this, if I do the plug setting to 50%, what does it mean is, whenever there will be 150 amperes flowing, at 150 amperes the disc will start rotating. Okay, whenever current of 150 amperes or more is flowing, the disk will start its operation and it will indicate that now we have to trip. Why? Because the setting is 50% and current has reached to 150 amperes. Similarly, if the setting is 70, and the second setting that we have to do is this time setting that we can do from here. So it can be done to 0.1, 0.2 seconds and so on. So on what this time setting will mean is whenever there will be 150 ampere and the disk is start rotating, so within 0.2. So as we have discussed the settings for electromagnetic relay, for numerical relay also the settings remain same, but the only difference is that we can manually enter the type of setting we require for this kind of numerical relay, and as it is microprocessor based, the settings will be calculated automatically, so no required to do manual setting for the disk or for TMS as we have seen in the electromagnetic relay. So friends, now let us see the electrical connections from the CT to the overcurrent earth fault relay, how the connections are done for numerical relay. So as we have already seen in our CT wiring videos that how the connections are done from CT through MK box to the panel, and from the panel using this TTB we give all the 4 connections to the numerical relay. On the other side of the relay there are other contacts that we have to use for the breaker tripping command through the master relay. So for that we have a positive supply, we provide positive supply from protection DC, and other contact is connected to the tripping contact or the post close supervision contact inside the circuit breaker, right? And similarly connections are done for annunciator. One end is connected to the common and other contact is connected to the respective window, okay? And other contacts can be used for different kind of purposes. For example, if we want to use it for disturbance recording, then that kind of contacts can be used. So this is all about numerical relay. One thing, there are few advantages of numerical relay or electromagnetic relay. First one is, as it is microprocessor based, this is called a static relay. Why? Because compared to electromagnetic relay, this relay is not having any moving contacts. Okay, so all the contacts are fixed, no contacts are moving, so this is called a static relay, and because of that it has higher advantages over the electromagnetic relays. Normally in the substations nowadays, maximum number of relays are turning into static or numerical based relays, and very few relays are electromagnetic relays. So friends, that's all for the relays, overcurrent and earth fault relay. I hope you have understood the concepts of both kind of relays and how the connections are provided. If you have any doubts about settings or any other queries, please let us know in the comments below. Thank you.